So in this problem we have to find the current through each of the branches. So there is a current source and there are several resistances. So to do that, what I will first try to do is we'll try to minimize the circuit. So that's our 50 ohms there, 50 milliamps there, and then 10 kilo ohms, then there is this 5 kilo ohms, 2 kilo ohms, and then 9 kilo ohms, and then the combination of 18 and 6, that will be parallel combination, 18 times 6 divided by 18 plus 6, so that's 18 times 6 divided by 24, which gives us 4.5. So 4.5 kilo ohms, and then this is 9 kilo ohms, this is 2 kilo ohms, and this is 5 kilo ohms, and 10 kilo ohms, and this is 10 milliamps. So we will try to minimize the circuit as much as possible. So basically we plan to apply current divider rule. This current is 10 milliamps, and if we can reduce this part into just one branch, then we can apply current divider rule. So 9 kilo ohms and 4.5 kilo ohms, these two parallel again, so that is 9 times 4.5 divided by 9 plus 4.5, that becomes 3 kilo ohms. So now our circuit is reducing to a significant extent. This is 10 kilo ohms there, 10 kilo ohms, and then we have 5 kilo ohms, 2 kilo ohms, and then 3 kilo ohms. So this is 3 kilo ohms, parallel of 9, 18 and 6 basically, 2 kilo ohms and 10 kilo ohms there, and this is also 10 kilo, sorry, that one was 5 kilo ohms here. So basically what we have now is these three are in series, so we have, if we add them, it becomes 10 as well. So 10 kilo ohms, 10 kilo ohms in parallel, that means 50 milliamps will be divided into two branches. So this branch will have 25 milliamps, we now know that, and this is also 25 milliamps. So this 25 milliamps will also go through 2 kilo ohms resistance, but 3 kilo ohms is just the combination of those three. So what we will do now, we will just draw like that. This is because we have already found the current through this branch, and of course when this branch and this branch are the same, that much we know. We need to find current through these three branches. So in order to do that, we will just draw this part now. So this is our 25 milliamps, and here now we will write 9 kilo ohms, and then let's do 4.5 kilo ohms because we want to apply current divider rule. We will just use two branches at a time, so like that. So of course this 4.5 kilo ohms means it is the parallel combination of 18 and 6 kilo ohms. 6 kilo ohms there and 18 kilo ohms. So these two parallel combination, 18 kilo ohms, 18. Yep. So we can apply current divider rule for this situation using this circuit. So that will be, let's say I9 is the current through 9 kilo ohms branch. That will be 25 divided by 9 plus 4.5 times, since we are trying to find the current through 9 kilo ohms branch, we need to multiply it with the resistance value of the other branch, which is 4.5. So that's 25, and this is 13.5 times 4.5. So that is 8.33 milliamps. To write it, 8.33 milliamps. So that's the current there. Now we need to find the current through the remaining current will flow through this, so that can be, we can just subtract from 25 minus 8.33 milliamps, so 16.67 milliamps. this is the current that is flowing through. So this is 8.33 milliamps, 25 milliamps is here, and then this current is 16.67 milliamps. This current is 16.67 milliamps. So if we draw that part only now, we have 18 kilo ohms there and then 6 kilo ohms there, like that. So 18 kilo ohms and 6 kilo ohms, and we have here 16.67 milliamps current flowing. So how the current is divided between these two branches, if we want to find, we can say I6 is the current through 6 kilo ohms resistance, so I will multiply by 18, 16.67. So basically these two branches, since I am trying to find the current through 6 kilo ohms, I will multiply by the other, which is 18 in this case. So that's 12.5 milliamps, and the remaining one will be, that means current through 18 milliamps will be, I don't have to apply current divider's rule again, I can just subtract from 16.67 just like before, minus 12.5, and that is 4.17 milliamps. So now we know the current through each of the branches. So this is 25 milliamps. This is very clumsy diagram, but whatever, this is 25 milliamps as well. And then we had 8.33 milliamps there, and then here we had 4.17, and here we had 12.05. So that's how this 25 milliamps is divided. 8.33 here, 4.17 here, and then 12.05 here. So we know the current through, we know current through all of the branches basically.